Hi again everybody, welcome to my latest video. Well, this is part 5 in my network build, my new network rack with 10 gigabyte network support. And in this part it's going to be sort of like a mixture of different things, a hodgepodge as I used to say. And I'll include here some lessons learned, some changes that I made to it, some slight changes that I'll show. The biggest thing is I'm going to include some performance testing. I actually got the server version of iPerf3 working on my server, and I was able to actually connect 3 different computers up to it and give the different performance testing. Over there is my current backup editing computer. It has a 2.5 gigabit network adapter built on board. The one behind me is my new backup editing rig, and I added to this one another 10 gig network adapter, and I tested that off with the server. In addition, I retested, my main workstation here against the server, and I think I did a test even between these two workstations as well to show the relationship between those. So there's a lot of performance testing that I did in this particular video. I'm going to start off with one of the lessons learned. I'm showing here a little piece of cable. This is a 2-foot Cat-7 cable, one of my little jumper cables that I purchased. Remember, I purchased like 10 of those for my rack. Well, this one I had connected up to my server. And if you look very carefully here, there's a kink in the cable. Now that was caused by my pushing it in a little too far into the cable management unit. And it kinked the cable to the point that the server would intermittently jump down from 10 gigabit down to 1 gigabit. It still worked, but very slow. It was driving me crazy until I troubleshot it, replacing that cable with another one, and then I realized that that was the problem all along. So just be careful if you build your own network rack that you don't overstress these cables in any way and don't cause an extreme bend in them, especially Cat-7. They're very sensitive to that. I also had a problem when I first hooked up this PC behind me directly to the 10 gig switch, and it did not run at all. It didn't connect at all. And I forgot that I had a little cable connected from the PC itself to my wall outlet, which was only Cat5, definitely not Cat6. The cable that I have in the wall for that connector is a Cat6. So once I replaced that little cable with a definite Cat7 cable that I have, then it worked fine as well. So these are just things you have to be aware of, when you go to a 10 gigabit network, that the cabling is particularly sensitive. Once again, if you get anything out of this video that you find useful, helpful, or you enjoy in any way, please at least consider subscribing to my channel. That would be very helpful. Well, let's get started. Let me start off by showing you how I used my Brother P-Touch labeler with black tape having white letters to actually put labels and to redefine some of the labels that are existing on my rack. For example, in this case, I'm showing how I renumbered 24 of the ports to numbers 25 through 48. I simply placed these replacement numbers over the top of the existing numbers, and they look pretty good, I think. Now here is some of the additional cable management that I did. First, looking down on the left side of the rack, I put plastic tubing wherever it made it look better. And here on the right hand side of the rack. So everything is nice and neat now. I want to start by putting connectors in here that'll go directly to the server. 2 USB 3.0 and 2 HDMI connectors. That way I can go directly to the server from the front panel here. I have to start by removing these 4 blanks that I put in there earlier, so I'll just pull these things out and then I'll be able to install the other connectors that I now have. I will start with the 2 USB 3.0s. Now they're going to be connected to 2.0 connector, but that's okay. I'll keep it consistent for now. So I'll put the first one in. They're a little bit tricky to get in initially. As you can see, they're 3.0. There you go, it's locked in place now. Now let me do the HDMI connectors the same way. Here's the first one that I'll put in. There's only one way these things go, so you really can't mess it up. Okay, that one's locked. There we go. Okay, now let me connect 3-foot cables from the back that are currently connected to the server itself. I'll start with the HDMI and get those in place. Once that's done, I'll do the USB cables, which are connected directly to the server, and get those in place. Once that's done, I'll be able to access these connections from the distribution panel. Now, something that has bothered me is this giant loop of fiber. So I bought a 7-inch fiber to replace that. So on here, I'm going to actually replace it, and hopefully it'll make it look a lot neater, and maybe it could at least partially tuck that inside the cable management compartment. I first have to remove the existing 18-inch fiber and get that out cleanly without causing it damage, because I may use that in the future, you never know, so I'd rather not damage it. Very gently get it out of here. I'm going to put those little covers back on that one. And then I'll install the existing new 7-inch one that I bought. And we'll see if it works okay. I'm going to try not to stress that cable too much. But then I realized that I have to actually move the port that it's connected to on my 1 gig switch. It won't reach the last port, so I'll have to put it on the first SFP port. So I just pull out this little controller and I'll put it into the other port. No big deal. Should work fine. Let's make sure that I get it in cleanly without causing any problems, however. It's going to go in there. You got to open the latch on it before you install it. There we go. Push it in till it locks in place. And then I can install the fiber on it and see what happens. If I start seeing traffic going between the two routers, then I know that it worked fine. Snap it in place. Tuck it in out of the way a little bit, and let's see if it has traffic showing. This diagram shows the test configuration I used during these performance tests. As you can see, there's 3 workstations and 1 server that the tests were conducted upon. I've now connected a monitor through the actual distribution panel connections that I just added, and I'm going to start doing some performance testing. Let's see how this thing boots up first. And it has booted up successfully, no problems at all. Okay, I was able to get iPerf 3 loaded over to my server by mounting the SSD from Windows. The SSD that's within my SigmaNAS server, that is. And if we look here, I am in the mount directory for the SSD data, and I've loaded in the iPerf. And I've already gone down to the area where the executable is, the /bin. All the way at the right hand side there. That's where Unix in general and FreeBSD follows that, where executables would get installed. So now I'm going to go, let's see what's in here. We got 1 file, iPerf 3. Let me run iPerf as a server. Now it's listening. So iPerf 3 is running on my server right now, and it's listening on this IP port. So any connections that come in from a client version of iPerf will be answered here. So now over on the right hand side of the screen here, I've put up my Windows command prompt window. And over here I'm going to run the Windows client version of iPerf against the server. So I'll do iPerf and I'll run this one as a client, and now I have to specify the address of my server. Let's see what happens here. It's running on both simultaneously. On the left, the server is answering it, and on the right, the client is requesting. So now what I'll do is I will do it again in reverse. So all I have to do on the client end is add a capital R at the end. And now it'll switch to reverse and server roles. And as we can see, it looks like we got an average of just under 6 gigabits per second, no matter which direction that we did this in. Okay, so we know how it performs. It's not running at 10, but it's running at a lot more than the 1, which is good. In this screen capture, we saw the results of running the backup workstation against the server. As you can see, for some reason, it's running slightly slower. I guess there's a difference in the 10 gig cards that are installed on the two. And finally, in this screen capture, we're showing the results of the performance between the two workstations, the primary and the backup. As you can see, it got even a little bit slower here, which sort of makes sense because the workstations aren't going to be able to support the handling of the transfer as well. Okay, I just want to show you how I organized everything here. I bought this plastic box. I'll try to put a link down to it. I think I got it from Amazon. But it has a lot of different size compartments to it. And I put all of my rack accessories that I had left over at the end of installing the rack. So for example, right here in this compartment here are some keystone jacks, and these are the ones that you would wire. I didn't use any of these yet, but I expect as I add Cat-7, because it's a Cat-7 keystone, as I add Cat-7 wires in my house, I'll probably wire those in. That'll save me some time rather than putting plugs on the end. And then I still have a couple left of these ones that are just passed through Cat-7, so I might use, I have like 3 of those left. And then I have a bunch of other miscellaneous stuff in here. I have some Cat-6 keystone, the wired type. It's actually in 2 parts. And this is if I decide to redo some of my Cat-5 to Cat-6, because I don't need everything around here to be Cat-7. I have these. Don't know if I'll use many of those or not. I have here all of the rack screws that I had left over, and this includes the ones that came with the rack itself, along with the package that I bought of, I think, an additional 50. So I got a lot of those left. I got all the rack screws that came with the various pieces that went into my rack. These are the ones that are of different types and different styles. They're meant for slightly different connectors. They come with separate little nuts if you happen to have the square openings on a rack. I didn't use any of those. I don't know if I'll ever will. These are the RJ45 protectors, little rubber protectors, because I want to keep everything covered so dust doesn't get in there. I have some blanks in here for the distribution panel if I need any more of those. And then over here I've got the actual Cat-7 RJ45 connectors. They come in 2 parts. They have the little plastic piece you initially feed the wires through, and then this here. And I got my new crimping tool that'll cover Cat-7. And that's what I'm going to show next, how to create a wire out of this. And then these are the plastic strain reliefs that go on to the Cat-7. And they're of the right size that are needed for the cable that I purchased, that roll of Cat-7 cable. Just wanted to show how I have it all organized. Okay, what I'm going to show here is to make a Cat-7 cable. I have here the supplies, which is a Cat-7 RJ45 connector, and this one has a little accessory guide for lining up the wires, similar to the one that I showed in my previous video about a Cat-6 and Cat-5. And I've got the appropriate strain relief to match the cable. I've pulled off 25 foot of this cable from my spool, and these I bought specifically because they fit perfectly, diameter-wise, around this cable. So I'll put this on first before I put this on. It's not as important at this end, although I don't want to run it 25 feet, so it's always good to put it on first. Now, as I said before, we got to be careful with this. These Cat-7 RJ45 connectors, since they are shielded, the extra shielding is what helps it provide the higher frequency transfer. It is different. Here's a Cat-6 one, for example, which is not shielded. There is a little plastic piece, as I showed before, that sort of gets pushed in, and that will capture the cable, the Cat-6 or Cat-5 cable right in there when that gets pushed in by the crimping tool. This one does not allow for that function. You do not want to damage the casing of this. That's why they give you this extra piece here that you'll bend into place, and you crimp this around the cable to hold it so that it's sort of like a strain relief. This tool here that I bought is a new one, as I think I showed last time during my parts. You have to make sure that it's properly set. So there's a little adjustment here, whether it's Cat-7 or Cat-6 or below. Right now I have it set for Cat-7. If I take this little screw out here, pull it out, and then move this up, and then put the screw into that lower hole, the screw hole doesn't move. This little metal piece moves. Then it would turn it into a Cat-6, which would cause the crimping of that extra component. Which, as you can see here with that particular piece, right now when I push it all the way down, this little crimping knife does not come into contact with the RJ45 connector. If I had it in the Cat-6 mode, this would be up higher, and that is the piece, that little blade there. It's not a sharp blade, it's a dull blade. That'll come up and crimp into the actual RJ45 connector. So now it's set right for a Cat-7. And then over here, there's an extra crimper that's provided that crimps the thing on the back, that metal piece on the back of the Cat-7 connector. And I'll show you that. But I have the cable here. I've put this on, as you just saw. Now I have to free up some cable here. So let me use my really fine cutters, and I'm going to, without cutting the wire, I'm just going to get this started. Now some of these have a little string here that you can catch a hold of and pull. Let me see what this one has. Now you gotta be careful, because this one has a metal grounding wire on the shielding. This thing is double shielded, and it's got a metal grounding wire, stranded grounding wire that's coming through as well. There is no way to pull it like we had with the Cat-6 cable, so I'm going to have to cut it down as much as I need without damaging this little grounding wire here, this little stranded grounding wire that you see wrapped all around here. Now I don't want to damage that as I cut down onto this. I need a little bit over an inch to play with here. And once I got it down far enough, then I'll just cut around it again, being very careful not to cut the stranded wire that's wrapped around the shielding. I always try to neaten it out a little bit. As I said, the biggest difference here with the Cat-7 versus the Cat-6 is this extra shielding that you have, which is very important to keeping the electrical noise from causing problems in the transmitted bits through here. So I think that's about right now. Let me sort of unravel this a little bit. This has to go underneath. Here. This little copper wire is the critical one here. That's part of the package as well. So that's what I was trying to protect with that. So now I got to sort of pull this shielding back. And if you notice, every pair itself is now individually shielded, as I showed on my previous video. Now we got to open up these individual ones. It's sort of wrapped around there, so you have to sort of unwrap it. So each pair has one that has to be unwrapped. So that's the blue and the blue-white. Now, as you may recall, and I'll put it up on the screen right now, there are two methods of wiring these connectors. The same method applies to the Cat-7 as it did with the Cat-6. And this is by an international standard, TIA/EIA-568. And it has a B wiring and an A wiring. The A wiring was the original one, and they found out they were able to come up with a B wiring when they created crossover cables. And the B has sort of become the standard. By default, you wire these things according to the B standard. So we'll have to organize all of these wires appropriately into this little plastic connector. Now, unlike the one that I showed with the Cat-6, there is no ramp to this one. It is a pure rectangle. So I just have to feed them in the right order to this. It turns out this little piece, I hadn't used one of these before, it actually allows the wires to come through. Now make sure you can see the area that's completely wide open is where the wires go in, but the other area sort of has a separation to it, and the wire tips come out of that. So one has a little bit of a plastic cap on it, the other one doesn't. So after we get them all through here, we can then trim them to be even with this. This is to help organize the wire. So now let me see if I can feed them all through this thing. It's orange, white, orange. And I see the little plastic cover on this side here. You can see the reflection there. So I do orange, white, and they're offset slightly. So you put one in, and then the other one goes a little bit, sort of a half position in, sort of like that. And then the next two is green, white, which is the white, totally white one that's next to the green. It's the only way to know that that's the right one. So then we do the green, white, like that. And then the blue. Again, that's sort of going to be right next to the orange, like that. Then the next one is the blue, white. Yep, the blue, white. And then the green. And then the brown, white go back to making sense. So we did a brown, white. You should see when this is all done, all the whites are on the same half of it, and all of the colored ones are on the opposite half. So it looks like that. And then we can trim off the top of this without cutting the plastic. Be very careful with that. Use very fine cutters if you can. Okay, so now I got them all organized again. They're not very tight in there, that's why it's so easily for them to come out. So once I got them all in there, now I can put the connector in. The connector has to be properly oriented so that it is this way, with the tab at the bottom to match where the appropriate colors are going to go when we're in there. And we push the whole set of them in together. Until we're all the way in. And then when they're pushed all the way in, you could see the edges of the wire. Make sure you have enough slack in that wire to allow for that, okay? Because you got to push it all in. Then we'll take the crimper. We now have it set properly. We will put it in this way. Push the whole thing in, and then we'll give it a nice solid crimp all the way down. And we'll hold it for a few seconds. We'll hold that crimp in there. I like to wiggle the wires a little bit, the whole thing. Try not to crimp it a second time with this one. And then you sort of give it a little push from the other end, and you get it out. And then we can start trimming some of this shielding off. We'll trim off all of the individual shields so the wire pairs. We'll cut off that extra wiring that was in there. Do not touch this copper one. That copper one has to remain intact. So we trim off basically all the rest of it, and don't cut the wires by accident. So the shielding is off. Take this copper wire, and now we're going to bend this brace up like this to come up to this. Take this copper wire and wrap it around a couple of times. Wrap it around this little brace. That'll make sure we have the proper grounding to this cable. And we'll sort of hold it like this as we now go to the remaining part of the tool, which is back over here, and we're going to crimp down this holder. So we just sort of hold it in place. We crimp it, turn it a little bit, crimp it. We want to crimp it exactly around. You should see it folding over itself at some point, and then you know you're right, and you can just go all the way down and crimp it. And now we can cut off the excess from the copper. And then we can bring this up. We can lock this in place. And then I'll jump ahead and do the other side, and then we'll test it. Okay, we're all done now. I got both connectors installed, and I'm going to do a test. Let's see here. If you notice, the tester does have a shielded thing to it. So I'll put one at one end, and I'll put one at the other end. Okay? So now if I come over here, and I'll hit the test first. That's this one right here. It looks like a little network. So I'll hit that one, and there it is. It actually says, tested each of the lines and it's passed. It also identifies that it's a shielded cable. I think I've seen that before when I actually tested one of my shielded patch cables. Let me go ahead and hit this button now and see what the length is that it thinks based upon the inductance of it. 26 feet. So it came off and said that we are 26 feet of cable, which is close enough. I cut it to 25 foot. Okay, so now I have myself a nice little 25 foot Cat-7 cable. that I can use to stretch all the way across my, my den area here, which is really my lab and my computer room. Well, that concludes this video on the miscellaneous topics related to post-use of my new network rack with 10 gig support. In the next video, I'm going to actually show you the installation of a new server, maybe even two parts by itself, because I have to build that server first. Pretty much all the components are going to be different from what I currently have, except for the hard drives. The 6 terabyte hard drives that are in that current server, they're going to be moved over to the new one. Not sure what else I might move, probably not a lot, but we'll see what happens as we progress on this. Just stay tuned to watching this next video where, I get to see a major PC build, or in this case a server build, into the installation of this rack. Once again, if you got something out of this video that you found useful or helpful in any way, please consider subscribing to my channel, and also give me a little thumbs up if you can too. They all help. Well, until the next time, take care, be safe, and stay well. Bye.